As mentioned in the introduction to the course, there's a spectrum of different options in Google Cloud for compute and processing. We'll focus on the traditional virtual machine instances. Now, the difference is Compute Engine gives you the utmost in flexibility. Run whatever language you want. It's your virtual machine. This is purely an infrastructure as a service, or IaaS model. You have a VM and an operating system, and you can choose how to manage it and how to handle aspects such as autoscaling, where you'll configure the rules about adding more virtual machines in specific situations. Autoscaling will be covered later in this course. The primary work case of Compute Engine is any general workload, especially an enterprise application that was designed to run on a server infrastructure. This makes Compute Engine very portable and easy to run in the cloud. Other services, like Google Kubernetes Engine, which consists of containerized workloads, may not be as easily transferable as what you're used to from on-premises. So what is Compute Engine? At its heart, it's physical servers that you're used to, running inside Google Cloud's environment with a number of different configurations. Both predefined and custom machine types allow you to choose how much memory and how much CPU you want. You choose the type of disk you want, whether you want to use a persistent disk backed up by standard hard drives, or solid-state drives, or local SSDs, or cloud storage, or a mix. You can even configure the networking interfaces and run a combination of Linux and Windows machines. We'll discuss these options in more detail later in the module. Several different features will be covered throughout this module, such as machine right-sizing, startup scripts, metadata, availability policies, OS patch management, and pricing and usage discounts. Let's start by looking at the compute options. Compute Engine provides several different machine types that we'll discuss later in this module. If those machines don't meet your needs, you can also customize your own machine. Your choice of CPU will affect your network throughput. Specifically, your network will scale at 2 gigabits per second for each CPU core, except in instances with 2 or 4 CPUs, which you'll receive up to 10 gigabits per second of bandwidth. As of this recording, there is a theoretical maximum throughput of 32 gigabits per second for an instance with 16 or more CPUs, and 100 gigabits per second maximum throughput for specific instances that have a T4 or V100 GPUs attached. When you're migrating from an on-premise setup, you're used to physical cores, which have hyperthreading. On Compute Engine, each virtual CPU, or vCPU, is implemented as a single hardware hyperthread on one of the available CPU platforms. For an up-to-date list of all of the available CPU platforms, refer to the link section of this video. After you pick the compute options, you'll want to choose your disk. You have 3 options: standard, SSD, or local SSD. So basically, do you want standard spinning hard disk drives or flash memory solid-state drives? Both of these options provide the same amount of capacity in terms of disk size when choosing a persistent disk. Therefore, the question is really about performance versus cost, because there's a different pricing structure. Basically, SSDs are designed to give you a higher number of IOPS per dollar versus standard disks, which will give you a higher amount of capacity for your dollar. Local SSDs have even higher throughput and lower latency than SSD persistent disks, because they are attached to the physical hardware. However, the data you store on a local SSD persists only until you stop or delete the instance. Typically, a local SSD is used as a swap disk, just like you would if you wanted to create a RAM disk. But if you need more capacity, you can store those on a local SSD. You can create instances with up to 8 separate 375 gigabyte local SSD partitions for a total of 3 terabytes of local SSD space for each instance. Standard and non-local SSD disks can be sized up to 257 terabytes for each instance. The performance of these disks scales with each gigabyte of space allocated. As for networking, we've already seen networking features applied to Compute Engine in the previous modules lab. We looked at different types of networks and created firewall rules using IP addresses and network tags. You'll also notice that you can do regional HTTPS load balancing and network load balancing. This doesn't require any pre-warming because a load balancer isn't a hardware device that needs to analyze your traffic. A load balancer is essentially a set of traffic engineering rules that are coming into the Google network, and the VPC is applying your rules destined for your IP address subnet range. We'll learn more about load balancers in a later course of the Architecting a Google Compute Engine series.